Dear students, welcome back to SWAYAM program on information technology applications in libraries. Today, in the week 11, we are going to learn another very important topic, that is big data analytics in library management. Dear learners, this is today's agenda. We will be discussing traditional digital data, type of digital data, big data, its definition, and its characteristics, historical development, big data analytics, classification of big data, process of big data analytics, different platforms, and big data analytical tools. Then at the end, we will be discussing on the application of big data analytics in library management. We deals with a lot of data. The data which we call is a structured data or unstructured data. This traditional detailed data that refers to that information that can be easily organized, stored in a straightforward system like spreadsheets and small databases. It is a structured data commonly maintained by business of all sizes, from small enterprises to large organizations. This data This database uses centralized architecture to store and manage data in a predefined format with fixed fields. The structured query language, SQL, is used to manage and retrieve data from the traditional databases very effectively and efficiently. The data like geographical data, cultural data, transport data, or statistical data, financial data. These are the examples of the data we generally use in normal or in a traditional way. So this type of data is easy to store, manage, and handle with the help of computer systems and modern digital technologies. So now let us see what are different types of digital data. One is a structured data. The structured data is created using a fixed schema and it is maintained in a tabular format. For example, it is a SQL table. It's an example of structured data, or relational databases. This is another example of structured data. Semi-structured data like a XML format. It does not reside in a relational databases, but that have some organizational properties that make it easier to analyze. Next is unstructured data, in which it is not follow any predefined standard, or we can say that it does not follow any organizational format. Example, the Word, media, logs, etc. These are the examples of unstructured data. Now let us see what is big data. Dumbbell defined the big data as, quote, is data that exceeds the processing capacity of conventional database systems. The data is too big, moves too fast, or doesn't fit the structures of your database architectures. To gain value from this, you must choose an alternative way to process it. Unquote. So it is very clear from this definition that the big data is something having more processing capacity than the traditional one, and it is too big and it moves fast, and it doesn't fit with any structure of whatever the database we generally use for our traditional data. DeMoro and colleagues proposed another definition. They define big data as, quote, represent the information assets characterized by such a high volume, velocity, and variety to require specific technology and analytical methods for its transformation into values. So this is the definition is given by D. Morio and his colleagues. Now let us see why big data and what makes it big data. The growth of big data driven by key factors such as the expansion of storage capacities, allowing organization to retain massive volume of data, and advances in processing power, enabling faster and more efficient data analytics. The widespread availability of data from diverse sources, including Internet of Things devices, social media, and digital systems. It is estimated that in the year 2020, users generated 64.2 zettabyte data, which exceeds the number of detectable stars in the cosmos. See the size of the data which we are generating in a year. So the International Data Corporation, IDC, predict that the worldwide data will grow 61 percentage. That means it will grow up to 175 zettabytes by 2025. So it is a very alarming situation because of the growth of data is concerned. Now let us see what are the historical development of big data. The 1940s and 1950s, we witnessed the early data collection and storage. The detailed data storage begins with the magnetic tapes in the year 1940s, and in the year 1950s, IBM develops hard disk storage, facilitating larger data storage for business and government. In 1960s, we having the growth of data management because of the introduction of data management system DBMS to structure and organize the data. And in the year 1970s, we witnessed the introduction of a relational database and a structured query language. And in 1980s, we have data warehousing and business intelligence have been introduced. And this emergence of this business intelligence tools for data analysis with companies using these insights for decision making. And in 1990s, we witnessed another development, that is the digitization and data mining. So the digitalization increase in digital content creation due to the internet and digitization of the other printed materials. Data mining techniques emerge, enabling the deeper analysis of larger data sets and find the various patterns. And in the 2000s, we will having the rise of Web 2.0 and explosive data growth. Because of this, social media, e-commerce, and online service generate vast amount of user data. Traditional database struggle with the volume, velocity, and variety of data, making the rise of the term big data. The concept of big data was first used by Laney in 2001. In the year 2005, we had another development in the form of a Hadoop and distributed computing models. Apache Hadoop is introduced and inserted by Google's file system and MapReduce. Distributed computing and storage models help handle large data sets more efficiently. And in 2010, we witnessed another big data technologies and cloud computing. The emergence of NoSQL databases and big data platforms like Apache and Spark. The cloud computing also gains popularity during this period, which enabling scalable data storage and processing. And in 2012, the big data gains mainstream recognition. The US government launches the Big Data Research and Development Initiatives during the year 2012. And the same year, the big data becomes widely recognized as a critical asset across industries. And 2015 to present, we will be witnessing the impact of artificial intelligence, machine learning, and real-time analytics. So integration of machine learning and artificial intelligence for advanced data analysis. real-time data processing capabilities using cloud computing become more common with the tools like Apache, Kafka, and streaming analytics. In 2020s, big data and the Internet of Things, that is IoT devices, exponentially increases data generation. The focus on data privacy, security, and ethics as a big data continue to expand across sectors. Learners, now let us discuss about major characteristics of big data. According to the definition given by Lana in 2001, it is the big data is characterized by three V's. He called it a volume, velocity, and variety. The first V stands for the first V stands for volume, refers to the sheer amount of data being generated and collected every second across the globe. It includes structured, semi-structured, and unstructured data. For example, terabytes to zettabytes of data generated from diverse sources such as social media, IoT devices, transactions, emails, the sensors, etc. The second V stands for velocity, refers to is the speed at which data is generated, processed, and analyzed in a real time or near real time. Examples: social media feeds, stock market updates, and sensor data in Internet of Things systems. And the third V stands for variety, is associated with the diversity of data formats and types that need to be managed and analyzed. Example: data comes in multiple forms like text, images, audio, video, long sensor recordings, etc., are the examples of the variety of data in the big data. So these three V's form the foundation of big data, representing its key challenges and the potential for unlocking the values when managed effectively. Big data analytics. Big data analytics is a process of exploring big data to extract hidden and valuable information and patterns. Big data analytics helps organizations in more informed decision making. Big data analytics applications can be broadly classified as descriptive analytics, predictive analytics, and prescriptive analytics. Descriptive analytics can help identify and understand user behaviors, resource usage patterns, and other operational insights by analyzing historical data. Example: library material circulation trends, detailed resource utilization, etc. Predictive analytics can be highly valuable for forecasting user behavior, resource demand, and operational needs. Examples: predicting book and material demand, forecasting data resource usage. Examples of prescriptive analytics are optimizing collection development, personalized resource recommendation for patrons. Learners, now next is process of big data analytics. Data analytics, data scientists, data engineers together create data pipelines which helps to set up models and do further analysis. Data analytics can be done in the following steps, which are mentioned below: data collection, data cleansing, data analysis and data interpretation, data visualization. These are the major four processes of big data analytics. In the data collections, these steps involves gathering raw data from various sources such as databases, sensors, surveys, or various logs. The collected data should be relevant, accurate, and comprehensive to ensure a meaningful insight. Sources may include structured data like SQL databases and unstructured data like text files or images or social media posts. After collection of data, the next stage is data cleansing. In the data cleansing, it's a process of preparing data by removing or correcting errors, inconsistencies, and missing values. It involves identifying and addressing duplicates, outliers, and incomplete records to improve data quality. Tools and techniques like imputation for missing data or normalization for scale adjustments are often used for data cleansing. Data analysis and data interpretation is the next process. In this step, analytical methods and models are applied to extract patterns, trends, and correlations. Techniques include statistical analysis, machine learning, or data mining, depending on the complexity of the task. After analysis, the results are interpreted to derive actionable insights and make data driven decisions. The next stage is visualization. In these steps involved presenting the analyzed data in a clear and engaging format using charts, graphs, dashboards, and infographics. Tools like Tableau, Power BI, Matplotlib help communicate findings very effectively. Visualization helps stakeholders quickly understand by key metrics and insights, making complex data more accessible. Now let us discuss about various data analytics platforms. The first one is MapReduce. MapReduce framework represents a pioneering schema for performing big data analytics. It has been developed for a dedicated platform such as Cluster. MapReduce framework has been implemented in three different ways. The first implementation was achieved by the Google under a proprietary license, and other two implementations are Hadoop and Spark, which are available interestingly in the open source. The next platform is Apache Hadoop. The Hadoop framework was developed as an open source product by Yahoo and widely adopted for big data analytics by the academic and industrial communities. The main design advantage of Hadoop is its fault tolerance. In fact, Hadoop has been designed with the assumption of failure as a common issue in distributed systems. Another platform is Spark. Spark is a more recent framework developed by UC Berkeley. It is being used for research and production applications. Spark offers a general purpose programming interface in the Scala programming language for interactive in-memory data analytics or large data set on a cluster. The LexisNexis Risk Solutions originally developed high-performance computing cluster (HPCC) as a proprietary platform for processing and analyzing large volumes of data on a clusters of commodity servers more than a decade ago. It was turned into open source system in the year 2011. The major components of HPCC system include a Thor cluster and a Roxy cluster. So these are the important platforms. Now let us discuss what are the important data analytics tools. Now let us discuss, high learners, now let us discuss what are the major data analytics tools. Slice Machine, MarkLogic, Google Charts, SAP in Memory, Cambridge Semantics, MonoDB, Pentaho, Talent, Tableau. These are the major big data analytics tools. So you can use these tools for analytic purpose. Depends on your nature of data and your convenience to use these tools. Tableau is a leading data visualization tool that transforms data into interactive, shareable dashboards and visual analytics. Next is applications of big data analytics in library management. Enhanced decision making. Big data provides actionable insights from historical and real-time data, enabling library managers to make informed decisions. And it can be used for predictive capabilities. Libraries can use big data for predictive analytics to anticipate user needs, such as predicting demand for specific books during an academic sessions or popular trends. It can also forecast future membership growth or declining usage trends for proactive actions. Big data helps in optimizing the procurement and distribution of resources such as books, journals, and digital subscription, through which it will increase the efficiency in the supply chain operations. Big data also helps to improve inventory management, and it will also give pattern centered approach. Libraries can analyze the user behavior and feedback to understand their preferences and requirements better. This allows the design of user friendly spaces, services, and programs that resonate with the patrons' interests and the needs. Big data analytics, it will enhance the personalization of various services. Using big data analytics, libraries can offer tailored recommendations such as suggesting books, resources based on borrowing history or user profiles. Personalized alert of new arrivals, events, or overdue notices enhance user engagement and satisfaction. Dear learners, let us conclude with these remarks. Big data seems to be multifaceted and evolving term that has caught global attention and has led to creative brainstorming, changing and transforming rapidly the way we live, work, and think. Big data is a huge opportunities for libraries as it can lead to a creation of new roles for the librarians and the information professionals. Librarians have always been a vital part of the data and information sector. The main aim, therefore, is to be the main aim, therefore, is to be aware always of the evolving database research to facilitate knowledge creation in communities. Big data technologies already play an important role in some type of libraries, such as academic, engineering, and medical libraries, while some other libraries, such as public and research libraries, is to take still faster steps towards implementing a big data strategy. So this big data analytics is revolutionizing how libraries serve their communities, making services. So the big data analytics is revolutionizing how libraries serve their communities, making services smarter, more personalized, and impactful. Libraries adopting these technologies are better equipped to flourish in the digital age. So, thank you so much, dear learners, for your patience listening. Uh, I will be back with another topic in the next class. Take care.